All right, welcome to your 7.5 notes videos. This is part 2. Today we'll be going over adding and subtracting radicals. So we can add and subtract radicals in the same manner as adding and subtracting monomials. You can only add or subtract like terms or like radicals. All right, so if we look at a couple things here, um, notice we have like. When we say like, we mean that we have the same radicand. The radicand is what's underneath our radical. So we have a 3a here, a 3a here, and we have a same index. So we're taking the cube root of both sides. So because of this, we can add these two together. If we look at the other side over here, we'll notice that we have 2 times the cube root of 3a plus 6 times the cube root of 3. The indexes are the same, but we'll notice that the radicand, we have a 3a over here and an a over here. So we can't actually add these together. So moving on to our first example, let's look at number 11. We have 2 root 12 minus 3 root 27 plus 2 root 48. Notice that none of these have an index named, like none of them have an index stated, excuse me. So we know that they're all indexes of 2. So that gives us a hint that we can add these together. So it looks like we're actually going to have to simplify what's underneath the radical for us to be able to add these terms together. So if we just organize our thoughts here, we'll focus on this 12 first. If we factor this into its prime numbers, we can factor 12 into 4 and 3, and we can factor 4 into 2 and 2. And now all branches of my tree, so to speak, have a prime number. So if we rewrite our radical, we have 2 times, this 2 is from up here, 2 times 2 times 3, all the branches of my tree. So since we have an index of 2, we're looking for groups of 2 of the numbers. So we have a 2 here. So we'll pull 1, 2 out. So we have 2 times 2, and then the 3 will stay underneath the radical. So we have root 3. So 2 times 2, we have 4 root 3. All right, so if we look at our next term here, we have 3 root 27. So if we simplify our 27 here, or radicand, we have a 9 and 3 is 27. Then we can break 9 into 3 and 3. So if we rewrite our radical, we have our 3 from up here. So 3 times the square root of 1, 2, 3 3's. 1, 2, 3. Once again, the index is 2, so we need to look for pairs of 2, or groups of 2 numbers. So we have a group of 2 here, so we'll bring a 3 out. So we have 3 times 3, and we're left with 1 3 underneath. So 3 times 3 gives us 9 root 3. Then looking at our last term here, we have 2 root 48. We can break 48 into 10 or into 12 and 4. We can break 12 into 4 and 3, 4 down into 2 and 2. Notice these are still not all prime. We can break 4 down even further into 2 and 2. So all the branches of our trees have prime numbers, so we can rewrite our radical. So we have our 2 up here, up in front. So 2 times the square root, we have 1, 2, 3, 4 2's. 1, 2, 3, 4, and we have a 3. So we're looking for groups of 2 because our index is a 2. So we have one group of 2, bring out a 2, so we have 2 times 2. We have another group, so bring that out, so times 2, and notice we're still left with that root 3. So 2 times 2 times 2, that's going to give us 8 root 3. All right, so what are we adding or subtracting these? Well, we just look up above here. So we have our first term, 4 root 3. We were subtracting our second term, and then we were adding our third term. And now we can actually add these all together because they all have the same radicand and they're all of the same index. So adding these together, we just focus on their coefficients. So we have 4 minus 9 plus 8. So that gives us a positive 3. So we're going to have a 3 root 3 as our simplified answer. All right, so we'll go over another example. All right, we have another 3 term. So we're going to be adding these 3 together. We have 3 root 8 plus 5 root 32 plus 4 root 18. So if we just break these apart, once again, if it helps you to draw these little lines out just to keep your thoughts organized, if that works for you, you can do that. So if we look at our 3 root 8, we need to simplify our 8. We can break that down into 4 and 2, and we can break our 4 down into 2 and 2. So rewriting our radical, we have 3 times the square root, and we have 3 2's, so 2 times 2 times 2, times 2. All right, so we have an index of 2, so we're looking for pairs of 2's, or groups of numbers in groups of 2's, if that makes sense. So we have a group of 2 2's here, so bring out 1 2. So we have 3 times 2, and notice we're still left with 1 2 underneath the radical. So that gives us 3 times 2, which is 6 root 2. So that's our first term simplified. So if we look at our second term simplified, we're going to simplify our 32, so we can factor that into 4 and 8. These aren't prime numbers. We can factor 4 into 2 and 2, and we can factor 8 into 4 and 2, and we can even factor this 4 even further, so 2 and 2. So we're going to have 5 2's. So rewriting our radical, don't forget your coefficient. When you rewrite it, so we have 5 root and then 5 2's. So 1 2 3 4 5. Once again, we have an index of 2, so we're looking for groups of 2 numbers. So we have a group of 2's here, a group of 2 2's here. It's all confusing, so we'll bring a 2 out in front, so 5 times 2. We have yet another group. We'll bring another 2 out in front. And we have our lone 2 that's going to stay underneath the radical. So 5 times 2 is 10, 10 times 2 is 20. So our second term simplifies into 20 root 2. And then looking at our last term, we have 4 root 18. Let's factor this into 9 and 2. 2 is a prime. 9 we can factor into 3 and 3. So if we rewrite our radical, make sure you don't forget your 4. So we have 4 times the square root of 3 times 3 times 2. And once again, our index is 2, so we're looking for groups or pairs of 2's of numbers, like pair of numbers, excuse me. So we have a pair of 3's here. We'll bring that out in front. So we have 4 times 3, and we're left with that lone 2 underneath. So 4 times 3 gives us 12 root 2. And that's our third term simplified. So we're adding together the first 2 terms, if you look up here, and we're subtracting the second and the last. So if we rewrite this, we have 6 root 2, and we're adding our 20 root 2, and we're subtracting our 12 root 2. And because they all have the same radicand, and they all have the same index, we know that we can add and subtract these together. So we're going to look at their coefficients. So we have 6 plus 20, it's going to give us 26, and 26 minus 12 is going to give us 14. So we have 14 root 3, and that's going to be your simplified answer. Remember, you can always stop the video in case you need to pause something or make sure that you write something down correctly, but we'll move on to our next example. So if we take a look, you'll notice that we're actually multiplying these 2 together. So we have 2 binomials, 2 terms each. So if it helps you, I'm going to draw out the box. If we remember that we use the box method to help us factor things out, we can use that here as well. So if we have a 2 by 2, we're going to draw a 2 by 2 box. And so we'll just put our first term up here. So we have 3 root 5, and then we have a negative 2 root 3. And then for our second set of numbers here, we have 2 and root 3. So when you're multiplying radical expressions together, you're going to multiply their coefficients first, and then you're going to multiply their radicands together, and then simplify your answer. Those are the 3 kind of steps. So if we take a look at our first box, we're going to find the area technically. So we have 2 times 3 root 5. So this is technically 2 root 1. So we have 2 times 3, that's going to give us 6, and technically root 1 times root 5. So 1 times 5 gives us root 5. So if we look at our second box over here, we have 2 times negative 2. It's going to give us a negative 4. And technically, technically we can write 2 as 2 root 1 because we know that the square root of 1 is 1. So if we're multiplying inside the radical, or we're multiplying the radicans together, we have 1 times 3, and that's going to give us the square root of 3. So then moving on to our second row, first column, notice we have our coefficient here is going to be 1. So we have 1 times 3, that's going to be 3. And then we're multiplying the radicans together. So 3 times 5, it's going to give us the square root of 15. And then if we look at our last box here, multiplying those coefficients, we have 1 times negative 2 is a negative 2. And then we have our radicans. So 3 times 3 is going to give us the square root of 9. So now it's just a matter of simplifying what we have. So we technically have 4 terms. We have 6 root 5 plus 3 root 15 minus 4 root 3, and then we have minus 2 root 9. So you're asking yourself, how can I simplify any of these, or can I add these together? Well, we know that we can't simplify 5 any further. We can't simplify 15 any further, or 3. But if you look at our fourth term here, we know that the square root of 9 is 3, so technically we have 2 times 3. So that's going to give us 6, or negative 6. A negative 2 times 3 is negative 6. So our finished product is going to look like 6 square root 5 plus 3 root 15 minus 4 root 3, and then we're subtracting 6, and that's going to be your answer. All right, well, I think that's going to be the end of our notes video for today. I don't think there's going to be a Schoology quiz. We'll just go through the rest of the notes in class tomorrow, and have a good night.